Welcome back to another Anyone Can Code video. In this tutorial, I'm going to show you how to make a Fruit Ninja game in augmented reality using Swift Playgrounds, and I'll guide you through the process of using ARKit, SwiftUI, SceneKit, and more. But here's the twist. Apple's Worldwide Developers Conference is just around the corner, and they're holding their annual Swift Student Challenge. The winners get special prizes and have the chance to be invited to attend the conference in the US. Now, I've won the Swift Student Challenge 5 times, so if you're interested in entering, I can teach you a thing or two about creating a project with Swift Playgrounds. Today, we'll be using Swift Playgrounds on an iPad, and with this, you can even submit the game to publish on the App Store. So, whether you're interested in learning how to make a fun game or entering the Swift Student Challenge, this tutorial is for you. Here's more about what we're going to be making today. Today, we're going to be making a game called Health Conscious Ninja. It's about a ninja who's health conscious and also doesn't want to be sued by the creators of Fruit Ninja. But anyway, the goal of the game is to slice the healthy fruits and not the unhealthy candy. And every time you slice the healthy fruits, your score will go up, but if you miss the healthy fruits, or you slice the incorrect and the unhealthy food, your score will not go up, but instead, the game will be over. Without further ado, let's get started. Alright, so before we begin, let me just talk about what I have set up right now. So it's pretty simple. I just have an iPad with Swift Playgrounds, and you can just download that from the App Store. And also I have my MacBook here connected to my iPad through universal control, which lets me use my trackpad and keyboard to control my iPad, which is much easier than typing, in my own opinion. Also, you can use Swift Playgrounds for this tutorial on a Mac. I'm just using it on an iPad just because I want to show that is possible. Anyways, let's start off by creating a new app. So in Swift Playgrounds, just click plus to create a new app. And we've got a new app here, and there you go. Just click on it to open it, and there we go. So I'm gonna add some assets. So just open up the top left, or press the top left button, and they'll just bring up all the files that we have. And I'm just gonna drag in the assets for this tutorial. Now, what I have here is available down in the description. It's just a bunch of different 3D models from Blender. They're all the different fruits and different candies which you can actually slice up. And additionally, we've just got some sound effects as well as some textures and particles as well. All of these can be made through, I guess, Blender and Xcode. The 3D models were exported from Blender into a DAE file and then converted into an SEN file with Xcode. Now, I could have used USDZ files, but for this tutorial, it was just easier to use Xcode so I could manage the files. And then also, on screen is the scene structure. So it's just a scene and the different pieces of the objects in the scene. And then also on screen is how to upload files from an iPad into Swift Playgrounds. So, to start off with the UI, let's open up the app preview. Well, apparently it crashed before we even began. So let's just, this UI here is going to be pretty simple, and there's not really much to discuss about here, except for why this thing is crashing. That is the one thing I would like to talk about. But yeah, it's okay. We'll just add some text here. And actually, before we do that, let me just make this a Z stack. This is just so that we can put our game as well as the UI on top of the game. In this, we're going to add a V stack, which is a vertical stack, so we can stack our UI vertically. We can add some text saying score, and this will be our score, but we have no place to store the score yet, so we'll just keep it as a placeholder for now. Ooh, weird. Let's close that again. We'll make this a bit bigger by setting the font to the title preset. Just makes it a bit bigger. You can add a bit of a spacer as well. And now this is for if the game's over, we just want to have text saying game over with all caps, and then a system font with a size of 60. It'll be a bit bigger now. Also make this bold, and also add the foreground color and make it red. So text will be red now. Let's see if it loads. There you go. Cool. Now let's space this out. Add a spacer so it's evened out, and the game over will be in the center. Cool. And then let's add a bit of a padding, and then I'm just gonna put this up, and I'm also gonna check if the game has begun yet, but because again we also don't have any place to store it, we just have to use a placeholder. This, if true here, will just be whether or not the game has begun. So when you actually start the game, it will start showing all this UI. So, with all that said, here will be where we add the GameViewController, which will be a separate view. But otherwise, we do need a place to store all of our content, so we need to create a new struct, or actually, in this case, a class called GameData. This is an observed object, so when we actually update all the data within this GameData, it will actually update the UI. Actually. So all of our things that we're storing will have to be marked as published so that they can actually update the view. So we have one for game began. We'll set this to false by default. Another one for if the game is over, set it to false because the game isn't over yet. And one for the score, which will be 0 by default. Now we need to actually create this in our content view. Like create a new instance, we need an observed object variable called GameData for our GameData. Again, observed object is used, or sorry, this has to be an observable object, and this needs to be an observed object. Observed objects, yeah, like I said, change something inside it and it'll update the view. It's very useful. It's very cool. And from here, we can just replace all the placeholders with game data for game began, another one for game over, and another one for the score. Cool. We want to also add something for the GameViewControllerRepresentable, which again is our game. We also want to pass in the game data, which we'll do later, when we set up the GameViewController. And let's also just say that this ignores the safe area. Cool. Now we have an error because we haven't actually set it up, but this is actually all the UI that we need. And we can just continue right now just by opening up the sidebar, create a new Swift file, and this will be our GameViewController. Cool. Let's close this up so we have more space. And I'm just going to start off by importing all the libraries and APIs, or the libraries and frameworks that we need. So we have ARKit, which is an augmented reality framework. Will let us use augmented reality in our game. SceneKit for all the 3D rendering and all the 3D effects. AV Foundation is for the audio, so we can have a slicing sound effect. And SpriteKit, which is used to render the 2D swiping gesture. The nice little effects that we have. So to be able to actually bridge our ARKit with SwiftUI, since ARKit uses UIKit, we need to actually use a representable. And that's sort of our middleman here. So we have a GameViewControllerRepresentable. I realize my eyes kind of being covered here, but it's okay, I can still see. This will be of the type UIControllerRepresentable, as it represents a UI view controller. We can add an observed object here which will be our game data. Now we need some required functions. So there's make UIViewController, which isn't being filled out, but I guess I have to do it manually. So thanks for Playgrounds. But this is where we create our view controller, and this will return our game view controller, which we're going to make later. We also want one to make a coordinator, and this is going to be used to, I guess, process the data from the UI view controller and then pass it to the game data. And this will return a coordinator, which we'll create again later. And for update UIViewController, you need to underscore UIViewController, GameViewController, context, and that'll just be empty for now. Actually, no, it will be empty. We don't need anything in here. Oh, we actually have an error here. It doesn't conform. Oh, I think it's just because I haven't returned. So let's create another class for GameViewController, which we'll create. And there'll be a UIViewController, which will have, the errors are gone. So we can, in make UIViewController, we can just create a GameViewController, which will be our GameViewController. And this will be off, we also want to, no, that's it. We don't need anything else, I don't think. And then we can just return the GameViewController. And that'll remove all the issues, silence all of those. Now we need a coordinator, which will pass the data between the UIViewController and the game data. So let's create a new class inside the struct. And this will be this will follow a protocol called GameViewControllerDelegate, which we'll create right now. So let's create a new protocol, GameViewControllerDelegate, and this is essentially basically the same thing as our game data, but it's just used to, again, pass that data between. So we'll just paste in all of the game began, game over, and game score, boolean, integer, and get set here just means that you can read and write to the variable. So you can read from it, get its value, and also set its value. Okay, and then in this coordinator, we actually need to add these stubs here. So first of all, let's create a game data property, and that's where we can pass in our game data. And for this make coordinator, we can actually return the coordinator, and then with our game data, just pass that straight in. Game data. Now, because of this, we also need an initializer because it's a class where we can actually feed in that game data as an input, and so we can create our own game data and set our local game data to the game data input. Whew, that's a lot of game datas, but we're near the end. We just need to add our variables here. Game began, so that's a false. One for game over, false, and then our score, which is by default 0. And then now I added all these brackets here because we're actually going to add a did set observer. So when it's actually changed, we can change the game data through this coordinator. So did set, and then we can do game data dot game began equals game began, which is the value right here. And we can do the same thing here for game over, and another one for our score. There you go. Those are our 3 values, and that's a coordinator done. We've already created a coordinator, and we can actually feed this into our game view controller. So we're going to create a delegate variable here in our game view controller, and this will be off this will be something that follows the GameViewController delegate protocol. And I don't think I mentioned this, but basically protocols just follow a certain set of rules. So in this case, it has to whatever follows this protocol must have these three values or variables. This way, we can actually set our GameViewController's delegate to this coordinator, and then when we want to change the data, we just change the data off the delegate. And so that's how it links everything together. And because of our observed object, we can actually then update the UI automatically. So it all comes back full circle. And once this is done, we can actually get into the actual game itself. So you've got a GameViewController here, but we need GameViewController. We need to actually set its delegate to the context coordinator. Remember, this context is here, and this will actually bring in the coordinator. And then for this delegate property, I forgot to add an exclamation mark. It's just there to say, don't worry, this thing will be filled in, and it's not going to be empty or anything. Otherwise, GameViewController would be a bit worried. So let's set up our views. We've got an AR view, which is an AR SCN view, our ARKit SceneKit view, and we've got our SK view, which will be our for our particle effects from SwiftUI. And we also want a coaching view, and that's basically the thing that when you're actually setting up the game, tracking the floor, it will tell you what to do. That's a coaching view. It's like a coach, like, telling you what to do. So we've got an AR coaching overlay view, which we'll create later, and our we've already started delegate. Now we're going to add an anchor node, and this will be the container for basically all of our objects, the floor and all the fruits, and they'll be placed inside the anchor node. We need also another one called last touched body, and this is just to keep a record of the last thing that was swiped or sliced, just because we need to actually perform the slicing in a sort of separate area to where we handle our touches. I'll get to that later. Now our slice sound effect would be our AV audio player, and then we also want some swipe particles, and then that'll be an SK emitter node with a file named whatever the file for this particles is, which is called, and it's currently called swipe. Well, another exclamation mark to say that this thing totally exists and will not be empty or nil. And those are all our variables that we need to store. So, cool. We're going to add a viewDidLoad function. For some reason, there is no autocomplete. I'll actually close this and then reopen just to see if it will fix our issues here. Okay, there you go. So we need to call super viewDidLoad just so we can get the UIViewController itself to do whatever it needs to do. And there you go, we can set everything up. So let's first of all set up our slice sound effect. So slice sound effect path, bundle main path for resource. So this is basically us setting up the URL for this sound effects file, which will be a slash sound effect of type MP3. So it'll be if it's slash.mp3, it would be slash of type MP3. And then for our slice sound effect, we need to create a new AV audio player. So we need to try with an exclamation mark, AV audio player, contents of URL with our file URL with path, and that will be our slice sound effect path, and that will create a new audio player. And then just by the way, if it doesn't exist, the thing will crash because we do have try with an exclamation mark. So generally these exclamation marks are sort of guaranteeing that when you access it, it will exist and not be nil, which can be sometimes unsafe, so do be wary. This we are actually adding question marks here because they may potentially be nil if they haven't been set yet. Now, we have some other things. Oh, slice effects path, add an exclamation mark at the end, and then we can get this ready to be played. So slice effects dot prepare to play. Cool. And then we're going to set up our AR view, which is our AR SCN view. For a frame, we're just going to set it to the view.frame. And then, so just fill up the entire screen. We want to also set up the auto resizing mask. And there'll be flexible width and flexible height. Flexible height, capital H. So whenever you change the orientation of a screen, or if the screen size somehow changes, it will also change with it. We'll set the delegate to itself, so we can receive some updates about the AR view when it renders. And to compensate for this error, we actually are going to create an extension. So new Swift file, GameViewController, AR SCN view delegate. It's just a file name, so don't worry too much about it. But here we also do want to import ARKit and probably SceneKit. Would probably be useful. And then here, this will just be an extension of our GameViewController, which will be of type AR SCN view delegate. Now, the reason why I'm creating a new file here is just purely because it's all cleaned up and nice, because all the files are separate and we don't have all the code in one document. Makes it nice and convenient. And as you can see, this error here has been silenced because, again, this is an extension, so it's extending on top of the GameViewController, just in a different file. For our particles, we also need to set up an SKView. Our frame here is, again, view.frame. We can actually kind of copy and paste the same stuff. SKView. There you go. Let's make sure that this allows transparency, so you can actually see through it, instead of blocking the screen. And we can set the background color to clear. Then we can add our SKView, view.add subview. For some reason, the autocorrect is giving me just a bunch of different autocorrect ones, except for one that I actually need. So, how useful. Yeah, if you do have the Mac version, I do recommend Swift Playgrounds on Mac. It is better in terms of the autocomplete. Unfortunately, you do have to wait for it to sync with your iPad for iCloud for it to actually work, or just airdrop it if you want to test it. So it does have its downsides, I guess. Anyways, we're going to add a scene for the SK view. We'll make another one for the AR SCN view, but that's later down the track. SK scene, and we're going to set the size to just a view.frame.size. And our scene's background color, again, has to be clear. We actually have to set it so many times. But yeah. And then that's it. Oh, and also our swipe particle. We need to set the target node to the scene, so we can actually have a trail effect. Otherwise, if we leave it out, there is actually no trail effect on the dragging. All right, so we can add the swipe particle to the scene, and then we can also present the scene through the view. There you go. And that's the setup for the SpriteKit stuff. And then we need to add another one for when the view will appear. Which, as you can see, is not appearing as autocomplete. Oh, this is not good. You see, autocomplete is a programmer's best friend. Animated full. I'm just typing this all in manually. Ideally, you really shouldn't be typing it all out. It's like super unnecessary. Oh, that was convenient. But yes, we just have to again call our super. Now this is where we can set up our plane tracking. So config AR world tracking configuration, and then we can set the config plane detection to be horizontal. And then for AR view, we can run this, get our session, and then have the session run this configuration. So this will set up our plane tracking so we can actually play on the ground. Oh, and there you go. This actual live preview actually runs in the background for some reason, so it'll just ask you to access the camera, in which I'll just say, okay, yeah, that's okay. Otherwise, it won't work. But yeah, so arview.session.delegate, we'll set that to self, and with that, we also need to add AR session delegates. I think we can. Where am I adding this? I would be adding this in another extension. Plus, I'm going to call this touch gestures because this is also where we're going to handle our touch events, so we can actually drag and slice things. Again, same thing, another extension, and then AR session delegate. Cool. And that's all we need. That's an empty file, but the error will go away. Whew, okay. And then that's not done just yet. We need to add a coaching overlay, so coaching view. We already have it set up, so we just need to create the AR coaching overlay view. Frame is our view.frame, just with all the other views. Oh god. Okay, cool. And then auto resizing mask. Let's add that back in. Same stuff. We actually need to set a goal for what we actually want to achieve. So we need to set it to horizontal plane. We also need to have it give it the session which it wants to monitor. So AR view.session. And then view.add subview, and that'll be our coaching view. Cool. Now lights. I'm just gonna copy this in because it is a bit of just the same stuff, but I will walk you through what is going on here. So we have two lights here. We have an ambient light and directional light. And so what we have here is the ambient light is sort of just the general area lighting that's just sort of around you. And the directional light is sort of like a sun. It like comes in at one direction. So I have like a lamp here, which you can't really see, shining on my face, but it only goes one direction. Yeah, so as you can see, for each light with an ambient and directional, we're setting the type and intensity. Generally, the directional light has to be brighter than the ambient light because the ambient lighting is not really as bright, but it is still there. If the ambient light isn't there, it'd sort of be like us in space, where like everything is just completely dark. You have like one really light side and the other side is just pitch black. And then for each of the lights, we're going to add a light node, which will contain the light by adding .light equals to whatever that light is. And then we're going to add the AR view, add that to the scene root node. The root node is basically the node of the scene which will contain everything. And then for Euler angles down here, that is basically the angle that the light will shine on. So that'll just be, what I currently have it set to is, it's just like completely pointed down. That's not what I want. I want to have pi over 4. I'm remembering my maths. Pi over 4 is actually 45 degrees. So that's probably some good lighting. And then finally, we've got some AR view, and we're going to set this some physics world stuff. So gravity .gravity .y. We're going to set the gravity to -1 meters per second. So for reference, our Earth is like 9.81 meters per second squared. The moon is like, I think 3 or 4 or something. So this is some pretty low gravity, but this will just make it more fun to play with. So again, also we need to set our physics world's contact delegate. So this will, so we can actually find when an object touches the floor. And so we'll set that to itself. And again, one more GameViewController SCN physics contact delegate. Again, these are the files of names. I'm just adding the delegate that it's subscribing to. But anyways, same old stuff. Actually, it'll probably save me time. Oh, by the way, for the touch gestures here, I need to import ARKit because this requires the AR session delegate. There you go. And then I'm gonna, for this one, import SceneKit. So extension GameViewController, and this will be off the SCN physics contact delegate. And there you go. Oh, all the errors are gone. We are all good. Cool. We are reaching the 30-minute mark. So what I'm going to do is I'm going to actually end it here. Part 2 will come up next, and that's just where we're going to finish off the game. Hopefully in the second part. There's a bit of stuff, but I think we can get it done fairly quickly. Alright, so I'm going to end it off here. So thanks for watching. See you in the next part.